In this video, we will discuss operations with fractions. And by operations, I mean how we add, subtract, multiply, and divide fractions. Let's get started. One of the easiest operations is multiplication when we're dealing with fractions. And so we'll go over a technique or a procedure that we will be able to use in order to multiply fractions. What I do is I cross cancel if possible, and then I multiply across. All right. So no matter what numbers we have or anything like that, this is the process that I'm going to have, that I'm going to follow. All right, and so I'm going to look at this example. I have 15 over 16 times 14 over 25. What I mean by cross cancel is to look at your two. Right, for instance, I have a 15 here, right, and that's in the numerator. I'm going to see whether 15 has common factors with 16 and 25, right? Well, if it does not have any common factors with 16, but it does have with 25, and that largest common factor between 15 and 25 is 5. And so I'm going to divide 15 by 5, and I'll get 3, and I'll divide 25 by 5, and I'll get 5, right? That's what I mean by cross-canceling. Something with the numerator and the denominator you can cancel. Same thing is going to happen with the 14 over the 16 and the 16, right? They both have a common factor of 2, right? If I divide 14 by 2, I get 7, and if I divide 16 by 2, I get 8. Now that I've cross-canceled, what I'm going to do is I'm going to multiply across. Now, what I mean by across is the numbers that are on top, 3 times 7, that'll be 21. And if I multiply my 8 by my 5, I will get 40. And so my solution would be 21 over 40. And what I always want to do is to make sure at the end that my fraction is in simplest form. And since 21 and 40 don't have any common factors, that will be in simplest form. All right. And so this is how we will multiply fractions. Division is the inverse operation to multiplication, and so they are very related. All right. When I divide fractions, what I'm going to actually do is I'm going to change division to multiplication, and I'll multiply by the reciprocal. Now, first we have to talk about what the reciprocal is as a review. All right. The reciprocal of a number is, all right, so let's say I have the number 2. If I want to do the reciprocal of that number, all I have to do is put it under 1, meaning 1 divided by that number. So the reciprocal of 2 is 1/2, and likewise the reciprocal of 1/2 is 2. And so the way that a lot of people remember reciprocals is to flip the fractions. If you notice, 2 can be written as 2 over 1, and so if I flip that fraction, it'll be 1 over 2. And so when I see this example here, that 7 over 30 divided by negative 1/5, well, what I'm going to do is I'm going to change division to multiplication and do the multiply by the reciprocal of negative 1/5. And so this is how it should look. I'll have 7 over 30, so I keep my first fraction the same, change that division to multiplication, and I'm going to do the reciprocal of negative 1/5. It's still going to be negative, but this time it's going to be 5 over 1. All right. And now when I go to multiply, now I can cross cancel, right? The 5 and the 30 have a common factor of 5. 5 goes into itself one time and it goes into 36 times. And so those are our only common factors. And so when I multiply across, I'm going to get 7 times 1, and that'll give me 7. And I have 6 times 1, which will give me 6. Now, I've got to remember, this was a positive number multiplied by a negative number, and a positive times a negative is a negative. So my solution should be negative 7 over 6. All right. If I wanted to write my answer as a mixed number, remember you can do the division. That would be negative 1 and 1/6, right? 6 goes into 7 one time with a remainder of 1. So we get a negative 1 and 1/6. So this is 2 ways that we can write our solution to this division right here. All right. So multiplying, you cross cancel. Division, you multiply by the reciprocal and then multiply. All right. Now we're going to get to addition and subtraction, and I'm going to do 2 different cases. The first case we're going to look at is when we have the same denominator in our fractions. All right. When the denominators are the same, we don't need to do much work before we start to add or subtract. All right. What we're going to do is we're going to add or subtract the numerators. We're going to keep our same denominator, and then we're going to simplify. All right? And so I have this example here, 7 over 20 plus 5 over 20. In order for me to do that, notice first that I have the same denominator. So my answer should have that same denominator. And what I'm going to do is add the 7 and the 12. Remember, I have 7 parts out of 20, and then here I have 5 parts out of 20. So naturally we add the 7 and the 5 and we get 12 parts out of 20. Of course, we want to simplify. Notice that 12 and 20 have a common factor of 4. 4 goes into 12 3 times and it goes into 20 5 times. And so we get a simplified answer of 3/5. All right. So again, when the denominators are the same, you add or subtract your numerators and you keep your same denominator. All right. Now, to do add or subtract when the denominator is different, we have to know information about what we call least common multiples. And when I'm talking about multiples of a number, for instance, if I say 3, I want the multiples of 3, then it's like counting by that number, right? So if I count by 3s, I'll do 3, 6, 9, 12, 15, so on and so forth. These are all multiples of 3. And so when I have two different denominators, what I'm going to want to find is the least common multiple between those denominators, and a lot of people call that the least common denominators. All right. When I want LCM, when I want least common multiple, I'll say LCM instead of writing all of the words out. All right. In order to find the least common multiple, especially for really, really big number, we can go through that process of finding the prime factorizations of the two numbers in which we want to find the least common multiple of. Once we find the prime factorization, we're going to look and we're going to find the common numbers that they both have in common, the numbers that they both have in common. All right. Those numbers that they have in common are going to be a part of the LCM, but I also have to multiply them by the remaining numbers that they don't have in common. And the reason I do this last step here is so that I get a number that's a multiple of each of the given numbers. Let's look at this, explore this idea with this example here. It says find the LCM of 12 and 20. All right. Well, if I look at 12, all right, I'm going to go find the prime factorization of 12, right? Remember your first few prime numbers, 2, 3, 5, 7, so on and so forth. 12 can be written as 2 times 6, and 6 can be written as 2 times 3. Right? So I'm going to come over here and I'm going to write 12 as 2 times 2 times 3. Okay? 20 is even, so 2 times 10. 10 can be written as 2 times 5. So I can write 20 as 2 times 2 times 5. And so now that I have those numbers together, I'm ready to find my least common multiple between 12 and 20, right? Notice I've done my first step. Now I'm coming over here to find my common factors. Well, they both have a 2 in them, so that has to go into my least common multiple. They both have another pair of 2's, right? So that has to go into my least common multiple. All right? That's all the common factors that I have, a 2 and another 2. And now I'm going to go to the third step, which says to multiply the common factors by the remaining factors. So I've got to multiply this LCM, have a 3 as a factor, and I've got to have a 5 as the factor. And note, if the 3 is not in my LCM, then it's not going to be a multiple of 12. And if the 5 is not in my LCM, then it's not going to be a multiple of 20. So that's why we have to have the 3 and the 5 in there as well. And so my LCM is just 2 times 2, which is 4. 4 times 3 is 12, and 12 times 5 is 60. So my least common multiple of 12 and 20 is 60. All right. Now there is another way that you can find the least common multiple without going through the prime factorization process. All right. And it's very similar to what we started with when I was talking about what a multiple is. All right. For instance, if I count by 12s, right? And so with big numbers, this can get a little hard. So that's why we have the prime factorization process. But if I count by 12s, I get 12, 24, 36, 48, 60, 72, 84, so on and so forth, right? That's counting by 12. So all of these are multiples of 12. All right, if I do the same thing for 20, but count by 20, 20, 40, 60, 80, 100, so on and so forth, I have all the multiples of 12 and the multiples of 20. And so if I want the least common multiple, then I look at the multiples of 20 and 12 and see which one do they have in common that's the smallest. And that will be the 60. All right? So for numbers like 12 and 20, that may be easy. But for numbers like 157 and 385, that may be a little bit difficult, all right? And so that's why we have this process of going through the prime factorization to help us find the least common multiple, okay? Now we're ready to add and subtract numbers with different denominators, all right? What we're going to do is we're going to first find the LCM of the denominators, all right? So I didn't write this in the denominators. I didn't write this in the PowerPoint, but we're going to find the LCM of the denominators, all right? After we find the lowest common denominator, and that's when we start writing it as LCD instead of LCM, they're the same thing. We're going to rewrite each fraction as an equivalent fraction with the LCM as the denominator. So instead of having these two denominators being different, well, we're going to do some stuff, some multiplication, so that we can have the same denominator instead of having these two different denominators. Because when we have the same denominator, it's a lot easier to add or subtract. And then last but not least, we'll add or subtract. All right? I'm going to do that prime factorization process one more time just so we'll see it so that we can use that to find the LCD. All right? So I'm going to start with 12, right? 2 and 6 is the same thing as 2 and 3. All right, so I can write 12 as 2. Excuse me here for a second. That'll be 2 times 2 times 3. And then I'm going to find the prime factorization of 15. It's not even, so I'm going to go to 3. 15 can be written as 3 times 5. And so I get 15 as 3 times 5. And so when I find my least common multiple, I want to figure out what they have in common. Excuse me for a second. Let's find out what they have in common, which is that 3, which I was trying to circle here. And then I have to put everything else into that least common multiple. All right? So I only have to write the 3 once since it's in common. The other things I have to write once as well. All right? So my least common multiple will be 3 times 2, which is 6, times 2, which is 12, times 5, which is 60. So instead of writing these denominators with the 12 and the 15, I'm going to want to write these denominators with 60. And so I want to be able to do something, so I get a 60 in the denominator for my first fraction and a 60 in the denominator for my second fraction. All right? Now to do this, I've got to make sure that I come up with an equivalent fraction. All right? So I'm going to have to think of what number do I multiply 12 by in order to get this 60 that's sitting here. All right? And I have to multiply it by 5. All right? Now, I can't just multiply the denominator by 5 because it completely changes my problem. All right? So I have to go ahead and multiply the top by 5, because in all actuality, that's like 5 divided by 5, which they really cancel. All right? So I'm going to multiply the top and the bottom by 5, and that'll give me 35 over 60, which is the exact same thing if you simplify it down as 7 over 12. And so that's what I mean by equivalent, and that's going to be very, very, very important. I'm going to do the same thing with 15. What do I multiply by 15 by in order to get 60? Well, I multiply it by 4. And so if I do it to the denominator, I have to do it to the numerator, and so I get 16. Therefore, 7 over 12 minus 4 over 15 now becomes 35 over 60 minus 16 over 60, which is just a subtraction problem, right? When we subtract, we keep our same denominator, and we subtract the numerators. So I'm going to do 35 minus 16, which is, I believe, 19. All right? Notice 19 is a prime number, so this is in simplest form. All right, and so that's adding and subtracting when we have different denominators, which concludes our video.